going to use the equation of vibrometer to derive the equation of velometer. Start with velometer. So of equation of vibrometer, which we derived yesterday, was Z by Y is equal to capital, that is the amplitude, so that is equal to R square upon square root of 1 minus R square whole square plus 2 zeta R whole square. Alright. So I can write y of t is equal to y sine omega t, and correspondingly z of t will be z sine omega t minus phi, because there will be some phase lag. So y dot t is equal to y into omega cos omega t, and similarly z dot t is equal to z into omega into cos omega t minus phi. Alright. So substitute the value of z dot t in z in terms of z dot t. Right. So substitute the value of z here in terms of z dot t. From here. This value from this equation. Alright. So I get z dot t divided by omega into y cos omega t minus phi is equal to r square upon square root of 1 minus r square whole square plus 2 zeta r whole square. Right. And z dot t is the recorded value, and omega y cos omega t minus phi is the actual value. So in fact it will be omega y will be the actual value, and it will be with phase difference phi. Alright. So this is the equation that I get, and so recorded value of velocity divided by actual value of velocity is equal to r square divided by square root of 1 minus r square whole square plus 2 zeta r whole square. Right? And as r tends to infinity, this ratio tends to 1. Right? So this is the equation for velometer. Okay. Now we'll do a design problem on velometer. Any questions before I continue? Okay, so this is the first question. Design a velometer if the maximum error is to be limited to 1% of the true value of the velocity. The natural frequency of the velometer is to be 80 Hz and suspended mass is to be 0.05 kg. So I will write R, that is the recorded velocity divided by actual velocity is equal to R square upon square root of 1 minus R square whole square plus 2 zeta R whole square. Okay. So when R is equal to R max, okay, dr by dr is equal to 0. Okay. So when therefore the corresponding to maximum value R is equal to, it's called as R star is equal to 1 upon square root of 1 minus 2 zeta square. All this derivation we have already seen in the earlier lecture. Right? So I can write R, that is the ratio, as 1 upon 1 minus 2 zeta square whole thing divided by square root of 1 minus 1 upon 1 minus 2 zeta square plus 4 zeta square into 1 minus 1 upon 1 minus 2 zeta square. And it is given that it is recorded for 1% error. Alright, so R will be 1.01 or 0.99. Alright, so substitute that value in the equation. Simplifying this will give you R is equal to 4 zeta square upon minus 4 zeta raised to 4, square root of that. So, so you will get two cases. One first case 1.01 is equal to this, and second case is 0.99 is equal to this. Alright. So write the quadratic equation. One equation is zeta raised to 4 minus zeta square plus 0.245075, and that is equal to 0. Right? And other equation is zeta raised to 4 minus zeta square plus 0.255075. Right? So for let's consider only this equation, because we are not going to solve for all possible answers. So for this one, zeta square is equal to 0.570178 and 0.429821. So square root of that becomes 0.755101 and 0.655607. Alright. So I am going to solve for this value. Alright. So omega n is equal to twice pi into 80, so that is 502.656 radians per second. K is equal to m into omega n square, so that is equal to 0.05 into 502.656 square, so that is equal to 12633.1527 Newton per meter. just the summary of all the calculations. So this is for this value. Okay, I'm calculating for this value. Okay, so damping constant, that is what has been asked. Is C is equal to 2m omega n zeta. So that is equal to 2 into 0.05 into 502.656 into 0.755101, and that comes out to be 37.9556 Newton second meter. All right. Are there any questions?
Sir,
Yes.
so why you didn't take the other value of zeta?
We can take any of the values.
0.6.
Both the values are equally correct. You
Okay.
can take this value also. All right.
So, but the answer will come different, no?
Answer will come different. So your design will be according to this zeta, but it will satisfy the required conditions of what do you say, the error.
What about the second equation, sir?
What about the second equation?
We can take values from that also.
So that question you have to answer in the next quiz. All right. So C is equal to 37.9556. So based on that, uh, answer the next quiz, and this question I will answer it at the end of the lecture when we do the review of this quiz question. All right. So don't forget to remind me. In fact, it is been designed. So we are going to answer that question at the end of the lecture. Okay. So you have to answer the next quiz question. So open up your next quiz. Open up your quiz and answer the next quiz question. Which is the correct value of damping ratio that can be chosen for designing the system? Right. So these are the bunch of values. Out of this, which are the correct value of damping ratio that can be chosen for designing system? So that question you have to answer. Okay, so time is 9:26. So most of the solution is done. So I should give you like couple of minutes to answer the question. All right, going to the next question. So a spring mass damper system having an undamped natural frequency of 100 Hz and damping constant of 20 Newton second per meter is used. As an accelerometer is used as an accelerometer. Operating speed is 3000 rpm. Actual value is 10 meters per second square. Recorded value is 9 meters per second square. Find m and k. Okay. So recorded value divided by actual
So operating speed is 3000, no? Written.
3000 RPM. RPM.
Yes, yes. It is not visible.
Divided by, this is 3000. 3000 RPM. Is it visible now?
Yes, yes. It is too.
Recorded value upon actual value is 1 upon square root of 1 minus r square whole square plus 2 zeta r whole square is equal to, recorded value is 9, actual value is 10. Alright. R is omega by omega n, so that is 2 into pi into 3000 divided by 60, and omega n is 100 hertz, so 2 into pi into 100, so this ratio comes out to be 0.5. Okay. So substitute these values in this equation and find out the value of zeta. Right, so substitute r is equal to 0.5 in this equation and find out the value of zeta, and that comes out to be, right, so just a summary of calculation. So substitute r equal to 0.5 in this equation and find out the value of zeta, and zeta comes out to be 0.8190. Okay, that is equal to C divided by C critical. So that is equal to C divided by 2m omega n. Right. So only thing unknown here is m. Okay, C is given. How much is C? Damping constant is 20 Newton second per meter. So substitute C as 20 Newton second per meter. Omega n is known from the earlier calculation. It is given, omega n is known. So only thing unknown is mass. So mass, that comes out to 0.0194 kgs. Okay, and omega n is equal to square root of k by m. So calculate k is equal to m omega n square and find out the value of k and round it off to nearest whole number without decimal and answer the next question, that is question number 3, that is for stiffness. Time is 9:32. Again, I will give you a couple of minutes for that.
Sir, how much you have to round off?
Round it off to whole number, nearest whole number.
Oh.
So you have to write it without decimal. Just round it off to the nearest whole number. All right, time is up. Next question. Is everybody done? Can we start with the next question? All right, so we'll go for the next question. So question number 4, a seismic instrument with a natural frequency of 6 hertz is used to measure vibration of a machine running at 120 rpm. Okay. The instrument gives a relative displacement of mass as 0.05 mm. Determine the amplitude of displacement of velocity and amplitude of displacement, comma, velocity and acceleration of the vibrating machine. Neglect damping. Okay. So that is the data. So calculate. So Z by Y, that is relative amplitude upon the amplitude of vibration of the machine, is equal to R square divided by square root of 1 minus R square whole square plus 2 zeta R whole square. Right. So Z is equal to 0.05, unit is what? mm. Z is 0.05 millimeters, and R is equal to omega by omega n, so that is twice pi into 120 by 60 divided by twice pi into 6, and this comes out to be 0.333, and zeta is equal to 0. Alright, so substitute all the values in this equation. Z is known, only R is known, so only thing unknown is Y. Right, that is the amplitude of displacement. And amplitude of velocity is omega into Y, and amplitude of acceleration is equal to omega square Y. Alright, so calculate these values, and you are required to submit these two values in the quiz question. Calculate amplitude of velocity and amplitude of acceleration and submit it in the quiz question. So when you submit the answer, you have to reduce it to this form. Multiply whatever value you get, multiplied by 10 raised to minus 3, whatever acceleration you get, multiplied by 10 raised to minus 3, and this value should be a whole number. Okay. Answer.
So the fifth question is an MCQ.
What?
The fifth question is an MCQ.
Oh, wait. Okay, you can just refresh the screen. And answer the question. Just refresh the screen, that should fix it. Are you seeing the fourth question as fill in the blanks now?
Yes, sir. That's it.
Okay. So write it without units, and this number should be a whole number. That is, write it without decimal. So time is 9:41. So, a couple of minutes till 9:43. All right, time is up. Everybody's done. Can I go to the next question?
Yes, sir.
All right. Okay, so question number 5. A vibrometer is used to measure the vibrations of the base of a variable speed machine. The operating speed of the machine ranges from 500 to 1500 rpm. It is desired to keep the amplitude between 4% error. So amplitude measurement should be amplitude measurement, not amplitude. The amplitude measurement should be between 4% error. Determine the natural frequency of the vibrating system, natural frequency of vibration if the damping factor is 0.6. So you have to find the natural frequency of the system that should be designed so that this condition is met, this error condition, to keep the amplitude between 4%, that is met. All right. So the error should be 0 to 4%. All right, so we'll see how to solve this question. So n minimum is equal to 500 rpm. Therefore, omega minimum is equal to 52.36 radians per second. N maximum is equal to 1500 rpm. So omega max is equal to 157.08 radians per second, and you have to find out omega n. All right. So 4%, the value of this reading should be within 4% error, right? So 4% error is allowed. All right. So z minus y upon y into 100 is equal to 4. All right. So z by y, this becomes 1.04. All right, and zeta is equal to 0.6. All right. And z by y is also equal to r square upon square root of 1 minus r square whole square plus 2 zeta r whole square. All right. So square this equation, so I get 1.04 square is equal to r square divided by 1 minus r square whole square plus 2 into 0.6 into r whole square, or I get 1.08.
Sir,
Yes,
sir, r to the power 4 na?
r to
4.
the power
R
4.
is to 4.
Yes, r to the power 4. So 1.0816 is equal to r to the power 4 divided by 1 minus 2r square plus r to the power 4 plus 1.44 r square. Alright. So you will get a quadratic equation of 1.0816 r raised to 4 minus 0.6056 r square plus 1 is equal to 0, and the roots of this equation is equal to r square is equal to 4.428, or r square is equal to 2.99. So r comes out to be the root, that is 2.04, and r is equal to 1.7. All right. So these are the calculations, and based on these calculations you have to answer the next quiz question. All right. So to ensure the error is, okay, now here I have slightly modified the condition. In the question it is up to 4%. Here the error is, I am saying that it is, should be less than 4%. Okay, so 4% error is not okay. It should be less than 4%. Okay, so what should be the frequency ratio? Now just cancel this. Okay. R equal to R, R, R. Okay. Alright, so you have to choose from these choices. Alright, R is equal to, I hope everybody has understood the modification I have made. This part of the statement is not applicable for the E and F option. Yeah? So scratch that. So for A to D is regarding frequency ratio, and last two is regarding the natural frequency. So you have to select the correct option. Select the correct option. Options or options. Alright. So this is slightly rigorous. The time is 9:49. So I think you will need at least 5 minutes for this. So I will give you till 9:54. Any questions? you will need this graph of, you need to construct a graph of z versus y on y-axis and frequency ratio on x-axis to solve this question. So it is a hint. Without that, it will be difficult for you to. Yeah, any questions, please ask. Are you installing MATLAB on your PCs? Because next week I will not be doing the experiments that I have done for B4 batch, uh, for for B2 batch, for B1. So for B1 and B2, both are going to do the MATLAB for the next week. Alright. So if you have the program, if you have the software installed for ready with you, it will be good. Uh, you can get some hands-on experience with MATLAB and Simulink. Once you know some basics, then you can play around with it, and it is a very useful software. And the reason why we have to do it next week, because you will be installing it and it will be like for only for 30 days. The trial version is only for 30 days. It is a full-fledged trial version. So within the, if you wait, then that it is going to expire. So next week is the best option to do the MATLAB practical. All right, everybody is done. Can I go to the next question? Anybody needs more time? I guess everybody is able to solve it. Okay, good. All right, now answer the next question. So this is the last question in the quiz. So for an undamped vibrometer, the true response can be recorded when the frequency ratio is, select the appropriate option. Alright, so this part I leave up to you. You have to answer the last question. Let me change the marks for that. So since this is the most difficult, this one has the maximum number of points. Alright, this is the last question and I will give you 5 more minutes for this one. So the time is 9:55. So I will give you till 10 and after that we will do the review of the quiz. At 10 o'clock the quiz will be closed. So before that,
Sir, it is seventh question, na? You have written sixth.
in the okay, in the slide it is 7. It is 7. Question number 7. Earlier one was question number 6. This is question number 7. This one was question number 6. I hope you have marked it correctly. Yeah? This is not question number 5. This is question number 6. And this is question number 7. Question number 5 was this one. Question number 4 and 5 was velocity amplitude and acceleration amplitude. Question number 6 is the error, 4% error question. And question number 7 is the undamped vibrometer. I hope you have marked all the questions correctly. If not, please check it. What is the response? Or at 1 minute, all of you submit your answers. Yes, last minute, all of you submit your answers. All right, it is 10 o'clock. All of you have you submitted the answer? I am closing the response. Anybody needs extra time, let me know immediately. All right, once I close the response, I am not going to open it under any condition. So if any student has any issues with submitting the response, he should report it now itself. I guess everybody is okay. I am just closing. Okay, now we'll do the yes. All right, so I will do the quick review of the quiz. So first question was this velometer for 1% error, and we calculated for 1% and we got this group of equations. So in this half of this equation you cannot use because the roots are imaginary. All right, so this is not valid. All right, does that answer your question, Sudarshan? All right, so and here you can choose any one of the values, so both the answers
Yes,
are
yes.
acceptable as the answer to your quiz. Okay, now next question is that 4% error. Okay, now this needs a little bit of graph. All right, so construct a graph of z versus y on y-axis and frequency ratio on x-axis. All right, so all graph starts from 0. So I will just mark z by y on y-axis and then a point at r equal to z by y equal to 1 and r equal to 1. That is a resonance. All right, and then draw the graph. Graph peak will be on the right hand side of the resonance. Just approximate graph. So the thing you need to take into account that the peak should be on the right hand side of the resonance, and as r tends to infinity, then this graph goes to 0. All right, so this is when the recorded value is equal to the actual value. All right, this point is repeated. So the for our case it is 1.04, so it will be above this line. Sometimes everything just aligns itself funny. Okay, so this is r equal to 1 and this is 1.04 and draw a horizontal line. All right, and this cuts the curve at 2 points. This is 1 point, this is second point, and this point, first point is you get two solutions for the quadratic equation, right? So first point is r is equal to 1.73 and the second point is r is equal to 2.104. All right, so from the graph what can you conclude? So for to meet the error condition of error less than 4%, your operating points have to be these. So your r has to be greater than 2.104. All right, if you choose the value of r as 1.73, okay, and when you go from omega minimum to omega maximum, then this R is going to pass through this zone. Alright, and when it is passing through this zone, your error is going to go beyond 4%, which is not acceptable. Okay, so your R, has to be greater than 2.104. Alright, so now we have to solve for, because the question asked is the natural frequency, right? So you have to solve for condition where R is greater than 2.104. Alright, so omega by omega n is greater than 2.104. Now put omega is equal to omega minimum, so that is equal to 52.36 radians per second. Alright, so 52.36 divided by omega n should be greater than 2.104, or omega n should be less than 24.88 radians per second. Alright, so this should be your natural frequency. Natural frequency has to be less than 24.88 radians per second. Alright, so that is the for question number 5. Which question number?
Can you post the scores?
Pardon?
After this, can you please post the scores?
Yes. All right. Now let's go to this last example, question number 6.
Sir, sir,
Alright.
sir,
Yes. Yes.
sir, if R is less than 1.73, then also it will be less than 1.14.
See, at least somebody is thinking. See, so you are saying that it is in this region, right? But when you set R is equal to 1.73, and then your this will be corresponding to omega min, right? And you're going to go from omega min to omega max. Correct? So when you go from omega min to omega max, this R is going for omega, as values goes towards omega max, then this R is going to go to this region. It is not going to go to this region. Right? So they are going to fall in this region. So, and when you fall in this region, the error goes beyond 4%. Is that clear?
Yes, sir.
Yes,
Sir,
or no?
because of this condition, R can't be less than 1.73, no?
R cannot be less than, R has to be greater than 2.104.
Okay, sir, because of this condition, no omega mean to omega max.
Yes. See, the range of operating speed is 1000 to 1500 RPM. Okay. So when this goes from 1000 to 1500 RPM, R is fixed, right? So, and for this value, omega n will be fixed. Only thing that is changing for a given system, if you take R is equal to 1.73, omega n is going to be fixed for 1.73. Right? So only thing that is changing is omega. Alright, so omega by omega n is R. Now omega is increasing and omega is remaining fixed. So the R value is shifting in this direction. So somewhere if it is in between this range, obviously the error is going to be more than 4%. Alright. Okay, now I have to finish the last part. So z by y is equal to r square upon square root of r square, 1 minus r square whole square plus 2 zeta r whole square. And here it is given that for undamped vibrometer, so undamped vibrometer means zeta is equal to 0. So z by y is equal to r square upon 1 minus r square. And it is second condition what? The true response can be recorded. Okay, so when is the true response recorded? When z by y becomes 1. So when z by y becomes 1, r square upon 1 minus r square also becomes 1. So when you solve this, you get r is equal to root. Alright, so that is the answer to the final question of the quiz. Now let me take down the attendance and also post the scores. Any questions? I will just post the scores. Okay, I have posted the scores. Alright, that's all for today. Yes.
Sir, in question number 2, C, D will also be the answer now because they are the roots of the A and B.
Next question. Question number
2, zeta values.
question number 2. C and D. Yes, C and D are the correct answers. What? You got that as wrong?
Yes, sir.
Okay. No. Wait. Question number 2.
Sir, also third question 7659 we are
Just a
getting.
minute. Just a minute. Question number 2. A and B have been marked wrongly. So it is C and D. Alright. So just refresh. That should fix it. Yes. Next one. What was the next one?
Third question we are getting 7659.
Everybody is getting 7659. How many of you are
Yes,
getting
sir.
7?
Yes, sir.
Yes, sir.
Okay.
Yeah,
So
yes,
that
sir.
might be that round of error 7659.
Sir, you have put for the question only answer C and D, but the total answer is A, B, C, D.
Which one?
Second question.
Second question what?
Second question, the answer will be A, B, C, D. Zeta square, both the values, zeta, both the values.
The correct answer.
Yes, but you have only selected as C
That
and D.
zeta square value, those are not the correct answers.
Zeta square?
There it will be correct, na? Zeta, if zeta is A, then zeta square is equal to A square.
Or is it coming like that? That is purely by accident. Let me check. Alright, that has happened purely by accident. 0.655607. Oh, it is coming purely by accident. It was not designed to be that way. Okay. So A and B are also correct.
Sir, but
Yes.
we denote damping ratio as zeta. No, zeta square is not the denotion of damping ratio.
So if zeta square is equal to 0.571, so obviously zeta is equal to square root of that, right?
Sir, but that we have to assume no. So
Ah.
C and D option will only be correct.
No. These are also correct. A and B is also correct. Zeta square is the square of the damping ratio, right? Okay, and what was about the third question?
Sir, we were getting 7659 Newton per meter.
Okay. So that might be some round of error. 7659. Okay. I'll just add that answer. 7659. Alright, just refresh your answers. Question 1. C and D.
Sir,
Yes.
sir, in previous quiz, do that answer 1.75 and the second year is given correct. Then
Which one?
you given marks.
Which one?
I don't remember. You have posted an assignment that
1.83. No, 1.83 is wrong. Nobody has. I have asked the students who have got the answer as 1.83 to post their calculations, but nobody has posted. I think.
okay,
Has anybody
so
posted?
you have given the marks for 1.75, na?
Yes, 1.75 and 869.
Okay.
Alright, so you can just refresh your screen. That will fix your what is it, score. Any other question? 7685 will be also be okay. 7689 also will be okay. All right, any other questions regarding quiz? If not, then we will end the lecture.